I think it's very important to recognize that multi-agent approach is a good way to build a single agent. This has a very good root in the theory of intelligence. So back in 1986, Marvin Minsky had this society of mind theory. He proposed that the human intelligence or any other natural intelligence system often consists of relatively simpler processes, and combining them together, the entire system can exhibit more intelligent behavior. So when we say multi-agent, we don't necessarily mean each agent in the system is a powerful agent. You can start from a relatively simple agent, but once you compose them together and make them interact in a good way, they would exhibit a higher level of intelligence.
Welcome to AI in the Real World. I am Joanne Chen, General Partner at Foundation Capital. I work closely with startups that are reshaping business with AI. In the series, I have discussions with leading AI researchers. We'll explore how state-of-the-art AI models are being applied in enterprises today. In this episode, I'm joined by Chi Wang, a principal researcher at Microsoft and the creator of AutoGen, an open-source framework that combines LLMs, tools, and human input to build multi-agent systems. AutoGen has quickly gained traction and has been adopted by both academics and enterprises to create applications. In this conversation, Chi breaks down the core concepts behind agents, the pros and cons of multi-agent architectures, and the real-world use cases enabled by AutoGen. He also shares some of the open research challenges he's tackling and what excites him most about where AI is headed. I had so much fun chatting with Chi, and I think you'll enjoy this as well. Here's our conversation.
Well, thank you so much, Chi, for joining us and having this conversation. I think there's a lot of interest, especially in the market, around some of the real-world applications of agents and multi-agent models. Maybe we'll just do quick introductions. Like, what sparked your interest in studying and building the space? What drew you specifically to studying agents?
Yeah, that can date back to a very long time ago. In my childhood, I learned my first basic program from a very old Apple device for a snake game, and soon I learned some other even more interesting AI system, like a system that can predict fortune for human being. In those very early days, that was a rule-based kind of approach. And in college, I participated in like competitions, like using agents to build game players that can compete with other agents. So those are like some early examples that got me interested. I did study some data mining, text mining topic in my PhD. At those time, we were also studying generative models, interestingly, and generative language models. But those are very different from today's large language models, the new generative AI. Probably the younger generation didn't know those kind of earlier generative models. They were small, they were model restricted, mainly for understanding, analyzing text. But those are early efforts. And I've been interested in this space for a long time, and seeing all the progress. But like everyone else, really, the ChatGPT, GPT-3, kind of large language models were a big revolution, and that got me back into this space and started to work on this. So before that, right before that happened, I was mainly working on the automated machine learning for model selection, hyperparameter tuning, etc. It's generic for all kinds of machine learning models. But large language models are so new and interesting, and so I soon started trying my approach in these language models and found some interesting behaviors and applications. So that's where I got some insights into the applications building on top of these larger models, and found a larger space to work on, meaning there's a big opportunity to think about a larger design space by combining the models with tools, connecting with humans, etc., and build really complex systems. And I was looking for the right way to think about these applications and the right way to empower developers to build their application easily. And I found that agent concept happened to be the most intuitive, natural concept to reason about the behaviors of these models and different type of tools. And then relate it back to all the previous experience, early experience about AI agents. So then everything just pointed me to the same direction that, yeah, this is the right direction I should go for.
That's great. And were you doing this mostly in academia? At Microsoft, what was some of the places you were doing this from a timeline standpoint?
I was working on ultimately machine learning and hyperparameter tuning at Microsoft Research. I worked on an open source project called Flammo. And the and when I started using Flammo to tune hyperparameters for GPT models, for example, I was also in Microsoft Research and still building the same open source project Flammo. So everything about AutoGen was built inside this open source project until last October, we moved it to a standalone repo on GitHub. So when I started working on Flammo, I also started collaboration with academia. I have a collaborator from Penn State University who joined me since the beginning. Since the beginning of development of AutoGen, it was collaboration with open source community.
Awesome. That's a super good comprehensive introduction. Let's talk about some basics of agents, just so that our audience understands how it works. So let's talk about that, and then we'll talk about what you've built specifically after that. So from an agent standpoint, could you maybe just explain in very simple terms what is an agent? What are the core capabilities? Just to start.
There are indeed many different types of definitions of agents. When I think about it, I was looking for the most generic notion that can incorporate all these different types of definitions. And to do that, I really need to think about the minimal set of concepts that are needed when we think about them. And in our definition, we think about the agent as an entity that can receive messages, send messages, and generate replies to respond to other agents. We think this is the most, we think that's minimal set of capabilities the agent needs to have. Underneath, they can have different types of backends to support them to perform these kind of actions. Some of the agent can use large language models to generate replies. Some other agents can use tools underneath to generate tool-based replies, and other agents can use human input as a way to reply to other agents. And you can also have agents that mix these different types of backends, or have more complex agents that have internal conversations between multiple agents. But on the surface, other agents still perceive it as a single entity when communicating to them. And I think with this type of definition, we can incorporate both very simple agents that can perform relatively simpler tasks using a single backend. But also we can have agents that actually contain multiple simpler agents and compose a more complex and powerful agent. And you can recursively build up this type of agents. So then the agent concept can cover all these different types of complexities.
Got it. That makes sense. Could you maybe share some, pros and cons? I know there's complexity from a pro standpoint, right? When you have a multi-agent system, but there's also a lot of downsides of an infrastructure like that due to this complexity. Could you maybe talk about that a little bit more?
So I think it's a very interesting topic when we relate multi-agent system and single agent. I think there are at least two different dimensions we need to think about when about single versus multi. One dimension is about the interface. That means from the user's point of view, do they interact with the system with in a single interaction point, or do they see explicitly multiple agents working and need to interact with multiple of them. So that's from interface. And another dimension is the architecture. For example, a single agent interface can have actually multiple agents underneath running at the backend inside the architecture, but the users don't need to see them basically. So when we think about that, then the benefit or pros and cons are different. From interface point of view, in some application, it's better to have a single interaction point for the user to simplify it. But in other applications, for example, when the application about having multiple agents debate about the subject and users need to explicitly see what each agent says, in that case, it's beneficial for them to actually see the multiple agents' behavior. Or think about the social simulation kind of experiment. People also want to see all the differences in behavior. But on the other hand, for the system part, I actually think the multi-agent design of the architecture is easier to maintain and understand and extend than a single agent system. Because even for the single interface, single agent based interface, having some multi-agent implementation will make the system more modular and easier for developers to add or remove components or functionality, etc. I think it's very important to recognize that multi-agent approach is a good way to build a single agent. So this is maybe not people will not immediately think about it in that way, but when you think about it, what I meant earlier about composing relatively simple agents and build a more powerful agent, this has a very good root in the theory of intelligence. So back in 1986, Marvin Minsky had this society of mind theory. He proposed that the human intelligence or any other natural intelligence system often consists of relatively simpler processes, and combining them together, the entire system can exhibit more intelligent behavior. So when we say multi-agent, we don't necessarily mean each agent in the system is a powerful agent. You can start from a relatively simple agent, but once you compose them together and make them interact in a good way, they would exhibit a higher level of intelligence. We don't have a good single agent that can do everything we want yet. And why is that? It's could be because we haven't figured out the right way of composing the multi-agent to build this powerful single agent. But first, you need to have the framework that allows easy experimentation of these different ways of combining multi-agents. So I believe that if people practice this practice of using multiple agents to solve a problem, they will also have a quicker way to reach a point that they can figure out a robust way of building a single agent using this way. Instead, otherwise, there are just too many possibilities. There are too many ways to build this single agent. If every time you rewrite the entire system, it's not going to be easy to maintain and make progress. So that's why this modularity from a programming point of view is very useful. And on the other hand, you don't have to stop at there, right? You can always think about multi-agent system as a way to multiply that power, right? You can always connect them with other agents, and for different reasons. Even if the single agent, even when the performance of a single agent is good enough, you may also want to, for example, make this single agent teach some other relatively weaker agent, so that they can become better with low cost. So we have a technique, for example, called eco-assistant. That shows the example of doing that. This technique can use agents with different power, different capabilities. For example, you can make GPT-4 based agent with GPT-0.5 based agent. The GPT-4 agent is more capable, but also more expensive. But by using this GPT-4 agent teach a 3.5 agent, you can reduce the cost by a lot, but overall you can improve the performance even compared to using a single GPT-4 agent. I haven't seen a lot of people using that in that way, but some other potential benefits you can get from multi-agent system. Yeah.
Could you share some more use cases and examples that are enabled by multi-agents, especially in the real world? And also, what do you see in terms of new possibilities in the future with this?
Sure. Yeah, as I mentioned earlier, there are at least two types of applications that benefit from a multi-agent system. One is the single agent-based interface. When you want the agent to perform increasingly complex tasks, you often find that you need to extend the system with different capabilities, tools, etc. And if you implement that single agent system with multiple agents, they can often increase the capability to handling more complex tasks or improve the quality of the response. So one example is when you want the agent to give you suggestions about data insights, when you want to perform complex data analytics, often requires agents of different roles to perform a task. Some agents are good at retrieving the data and present to others. Some other agents are good at having deep analytics, providing insights, and others agents can do critiques and suggest more actions, and some others can do planning, etc. So yeah, for usually to accomplish a complex task, you can build these agents in this way with different roles. And another type of application is where people want to explicitly make multiple entities of different roles perform functionalities. Like for example, in gaming, if you want to simulate a chess game, you need to have at least two different players, and those are explicitly built at different agents. Or if you want to build a like football game that will involve even more entities, and like I mentioned earlier, the multi-agent debate is another type of application where you want to explicitly watch different agent behavior, and social simulation will involve even larger number of agents.
Got it. Let's talk about AutoGen specifically, and then we'll go back to kind of some of these applications in the enterprise after. Could you start with giving us the backstory on AutoGen? What was the genesis, how it developed, what does the AutoGen technical architecture look like? So let's just start with the backstory first.
In the beginning, I was thinking about using the AutoML technique to optimize the hyperparameters for these large language models to find both high quality configuration, but bring down the low cost, to try to use the minimal cost to answer questions in a satisfactory result. And during that experiment, I found often to make the model to generate good result eventually for using in application, it's not enough to just do the inference once and directly take the result. Often there needs to be post-processing, checking whether they satisfy certain conditions, and if not, we need to change the way we prompt them, etc. So that makes me realize there are many different creative ways of using the language models, and then I found that agent abstraction is a very powerful way to leverage the most the biggest advance in these model capabilities. They are so good at performing conversations, for example, with human or with other agents. And if we leverage that well, we could potentially build multiple agents with different roles and make them talk to each other, and iterate over with our feedback and improve the performance. So AutoGen is designed to be such a generic framework to allow this kind of easy definition of agents and easily making them interact with each other for example, through the conversations. And it also allows easy integration with both different types of models, different kind of tools, and different ways of getting human participation. So it also unifies these different types of entities and allow natural human participation in these applications. And it's designed to be able to support very diverse applications on top of them. So we aim to AutoGen to be this generic fundamental programming framework for agentic AI, just like PyTorch for deep learning.
Got it. So the key components, are LLMs, external tools, human input, etc. They work nicely together with AutoGen's technical architecture. How does the system decide on using LLMs versus outside resources? Like, is this up to the person who's using AutoGen to develop?
Yeah, to a large degree. So we gave the developers full control of defining the different type of agents. We do have default behaviors for some built-in type of agents. For example, we have a assistant agent, which by default uses large language model to generate reply, and we give it some default system message to allow it to write code to solve complex tasks, and also instructions to debug the code and handle different kind of situations in the instructions. But we use that as just mainly as one example about demonstrating that you can add very complex instructions to an agent and give them the ability to exhibit different types of behavior. It's easy for them to customize that instruction and give the agent different roles. We also have a default user proxy agent, which is designed to act on behalf of the human. By default, it will ask for human input at each round. But if the human decides to skip the input, then the user proxy will invoke its automatic reply, for example, running the code suggested by the other agent or use tools suggested by the assistant agent, and then send the response back to the assistant agent. But these are mainly designed as basic examples. Developers can quickly build a useful application just using all the default agents. Just for example, using the two agents conversing to each other, they can do a lot of things already. For example, similar to what ChatGPT plus plugin and plus code interpreter can do. They can add more agents and customize the reply functions of each agent. They can give them different tools or add different types of capabilities using these customized reply functions. One really interesting way to customize the reply function is to use nested chat as a reply function.
Mm-hmm.
For example, in the application, having two agents talking to each other, one user proxy and one assistant agent trying to solve math problem. We will find that sometimes the student asks a question and the agent doesn't always know how to answer correctly. Then we can add this capability of having a nested chat inside that assistant agent so that this assistant is able to consult other experts, both expert agents and expert human, for example, teacher or lecturer, inside that nested chat. And once they finish the inner conversation, the original student assistant agent can take that conversation output back and send back to the student. This is a good way to extend the capability of agent by adding nested chat inside it. And you can recursively do this to enable even more complex patterns.
That's great. I know there are areas you mentioned this example. There's also, coding, gameplay, all sorts of other stuff that this works really well for. Could you give a few more examples?
Yes, there are indeed quite a few more interesting examples. I can categorize them by maybe the type of conversations a little bit. I mentioned one as nested chat. I want to mention a few others. One is called group chat. In that case, people design agents of different roles and put them together in the group so that each of them can send messages to everyone else and they all share the same context. Underneath, there was a group chat manager who doesn't participate in the conversation, but more performs the role like an orchestration. It will check the current progress of the chat and decide who to speak next based on their roles and the current progress of the conversation. This is also a very generic conversation pattern that is used by many different applications, including the data analytics, including making suggestions for like trips, like trip planner, including giving financial advice. So in many different applications can benefit from this type of group chat because if you find the agents are missing some aspects in their discussion, you could easily add agent to make them focus on a particular aspect. So then you'll, for example, in the planning, I see users defining different type of agents that some of them take care of the tourism, some of them take work schedule, some others take the gym scheduling, etc. So that then the final result presented will be more comprehensive. The multi-agent debate can also be easily independent in this way. But I do want to emphasize that this is not the only way to have multiple agents interacting together. Nested chat is another way. And the third way is you can have some hierarchical structure also using nested chat. And also even in group chat, you can have precisely specified transition condition from one agent to another, instead of all relying on the group chat manager to decide who to speak next. In that way, you can we can have developers to precisely define, okay, in what condition we can consider this task is done, and we can translate to another agent to perform the next task, etc.
Anything surprising or unexpected that you have found as you have seen people use this and through your work?
There are a lot of different kind of surprises. One is about the diversity of applications that people are trying. We did present a few different diverse examples in our initial study, but the way people are using it are much more creative and often give me new inspirations. I remember like one not so surprising application, but I think it's very promising is to use AutoGen to generate synthetic data, and then use the generate data to train, for example, small language models to make them possess new capabilities that they previously didn't have. One recent example is this all-car math effort. They use AutoGen to generate data that contain different examples of solving math problems. They can cover very diverse use cases and select the high quality examples from them. And using multiple agents, they could consider these different criteria required by the training data and select only the high quality ones. And eventually they gave the very small car model better performance in solving some, I think, primary school and middle school level math problems. And there are a few other examples I see just using multi-agent to challenge each other and teach each other, so that they can simulate the teaching learning behavior, and so you can also use that to then apply some reinforcement learning technique to improve the models. That's one promising direction of this multi-agent application. One recent example I found is using AutoGen to calculate wildfire area from satellite map. So that's the kind of very special and unique application that I wouldn't think of before I learned about it. It's about, like, for example, using the Google Earth engine to look at the map after wildfire happens, and then makes agents to call a bunch of APIs and try to calculate the exact area. I think one related kind of application is the embodied agents using both language models and vision models combine different modality and make interesting applications, like for example in robotics or in designing visual artifacts, like generate images, having some agent generate images, some other agents to criticize the quality and make suggestions. You can also take users' feedback and try to convert that into some agent understandable ways of improving the content.
Makes a lot of sense. Why don't we talk about just the enterprise software ecosystem, right? There's a lot of interest in these agent technologies. There's a lot of builders that are trying to do different things, but it's still very early in terms of adoption within larger companies, like in production. So curious from your standpoint, how do you see AutoGen being used in larger organizations or even organizations from a production standpoint?
Yeah, so that's very interesting. A common feedback I heard from the different companies using it is they are either thinking or starting to build some multi-agent framework inside the company to support their application. And when they found AutoGen, they realized this is the kind of the framework they're looking for. So then they could directly build their own agent platform on top of it, and instead of developing from scratch. So that's quite common, especially the larger is the company, the more they kind of need this common agent platform. Because, for example, a large company have different teams building different kind of agents. And if each of them uses a special different technique or framework, it's hard for them to later join force and build a more complex system. But having a common ground is kind of important for them. So we do see these two types of use cases. Now, one is like some organization uses AutoGen as a backbone to build their own agent platform, and others are using it for diverse scenarios, directly building applications using AutoGen. Yeah, I think both are pretty common across different size of companies.
Are there one or two that you're particularly excited about, or you just are really proud of just seeing it in the wild?
I didn't know that many companies are already using AutoGen until one day someone reached out to say, we've been using this for months and we're happy to share with you. Yeah. So one recent example is like Novo Nordisk. Yeah, I didn't know them using AutoGen until their VP of data science saying like they have been building a production ready data analytics platform using AutoGen, or like for pharmaceutical domain, and they want to enable everyone previously who wanted to participate in the community, but who were not able to do this kind of analytics to join. And they're also trying to extend AutoGen to address some like industry regulation requirements. Yeah, so this is like a very good example of a enterprise trying to use AutoGen as a backbone. They already can offer good value in their prototype or product, but they also need to extend them to address other issues to make them more mature and more customized to their specific needs. But data analytics indeed is, I think, one type of common applications I've seen.
Got it. That's great. That's a huge customer win, I think, given just the size and scope of the company. Very cool. Any advice you would give to the AI builders who are focused on the enterprise? How do they become successful, like the customer you just mentioned?
I think there can be many lessons to learn just based from all the developers' activities. So I think it's good to have both let's say creativity, right? And some level of grounding. I think both are good things to keep in mind when designing applications. For the creative side, I'm seeing that the practitioners really have amazing ideas. They probably have thousands of interesting ideas, and everyone have an opinion. For example, how AGI should be achieved by having some specific accounting architecture. I think those are very good source of inspiration. And indeed, I think the multi-agent concept opens up a really big space that everyone can participate and can experiment with their ideas. And some very good architecture could emerge from this kind of experiment. And so definitely people should try to be bold and creative and think about novel applications and experiment with them. And on the other hand, the more like kind of creative or novel, then the more unexpected failure can happen. Because if one of the agent doesn't perform as expected, it may affect the design of the entire system. So it may be also good to start from a smaller scale, like for example, having 2 agents in the beginning and try to put all the natural language model-based instructions in one LLM-based agent and put other tools in another agent, and see how well it works. If it already works pretty well, then you actually don't need to add more. But we often find that as the complexity of the task grows, because once they succeed for some simple tasks, they always want to go for harder tasks. That's very natural. And at some point, you will find it's not enough to have a single LM agent to address all the requirements. They may forget instructions and miss some steps. And then you may want to decompose the bigger task into smaller ones, and add more agents into the flow and try different ways of like making them perform. You can start with some more flexible way, just see if they can figure out that by themselves. If not, you can try to add more control into the behavior. Or if you already know what are the exact right steps, you can directly go for the more controlled ways. For example, you can define a sequential chats. You can define a series of steps of different chats. You can make one chat starts after the previous chat finish and use the previous chat information to start the next chat. And yeah, so just by setting right expectation, you will understand that if you give the agent more autonomy, then you'll also have the chance to see unexpected behaviors and adjust it when you need. On the other hand, if you use the prescribed steps, yes, they may follow the predefined steps, but they may also get more limited because if one step fails, they may also not understand. So the agent may get stuck and not able to recover from the failure. And in that case, you may also want to add the capability of having iterative conversation and give them some autonomy to recover from the failure, etc. So I think having the right expectation of what language model can do and in what case you need to add external tools to ground their behavior is also quite important. And one final advice is think about this human input mode. In AutoGen, you can configure different agents with human input or not. It's good practice to really start with human in the loop. And one benefit is that you can also make the human teach the agents using our teachability capability of the agent. So that unit can watch the behaviors of the original design agent and give them instructions. So that after they remember that instruction, next time for the similar task, they're able to use the previous teaching and perform more aligned with humans' desire. And only if you find that they have usually perform always expected, you can gradually make them more automated. We can also think about using AutoGen to build agents to do the evaluation, do the testing more automatically, because usually it requires a large number of tests for a human to be confident that the system performs as well expected. But for the language model based applications, it's often hard to do this kind of evaluation because the output usually in text form, and they often have vagueness in terms of like how good performance is. So that's also a big pain I've heard from many application builders. We are making some efforts, for example, building agent-based tools for evaluation and for benchmarking. These agents can, for example, check the logs, try to extract the right criterion and or perspectives to analyze the quality, and then score them automatically. And eventually, you can even think about using that feedback and provide that to other agents to improve their performance. But having this capability of using agents to, for example, simulate different users' behaviors, have some diverse type of behaviors tested before you put the system in actual use. I think it's also could be a good ways to leverage the large design space, the multi-agent systems.
Super helpful. Thank you. Let's take a look at let's look forward a little bit. AutoGen has seen very strong success so far. What are you exploring next? I know that, for example, you've looked at some brain-inspired architectures and to improve reasoning and planning. Is it a direction that you're going to pursue further? Curious what you're doing as a next step.
Exactly. Yeah. So that is one aspect. Let me try to give a high-level overview first, and then we can dive into some of them. On the high level, there are a few important open questions. They're very hard questions. For example, how to design an optimal multi-agent workflow for a specific application or task, and how to build highly capable agents while ensuring safety and human agency. So these are some example open questions and research challenges. The entire community is working very hard on solving them. The effort can be categorized into different dimensions, such as evaluation, optimization, learning, teaching, and interface. I can give you some examples for each of these dimensions. For evaluation, I already mentioned that people are building agent-based evaluation tools and benchmarking tools. They can often come into the aid to handle the large scale of testing or evaluation needed for system. And for the interface, this is where we're making very rapid progress on further making it easier, even easier to build agent-based applications. For example, we built a sample application called AutoGen Studio as a no-code interface for quickly prototyping the multi-agent applications, define the agents, define different workflows, and put them into quick experimentation, like by chatting with these multiple agents. That enables a lot more users to experiment with their ideas without writing code. And for developers, for Python developers, for example, we also offer some more high-level interface so that they can easily try different conversation patterns, like I mentioned earlier, like nested chat, sequential chats, group chat with finite state machine translation, etc. And for learning and teaching, that's very, very interesting type of capability we want to have agents to have to make them improve over time and remember teachings from users or from other agents, so that as people use them more often, agents become more capable over time. And for the integration, we were like actually integrating with new technologies like customized models, customized clients for using these models, new technology like OpenAI Assistant, multimodality, etc. So that we can incorporate latest technology into the multi-agent framework and offer them to the developers. In the particular topic you talked about this accounting architecture inspired from how human brain works is a good way to think about how to enable more complex task solving. For example, by decomposing tasks, making plans, monitor the behavior of agents, and replan when needed. Also validate each step, etc. We recently had reached a new milestone on a new benchmark called Gaia. It was a benchmark by Meta for measuring progress of the progress towards AGI, because they have very challenging problems that often involve multiple steps in solving these tasks. And we made some initial experiment, and our initial submission to that benchmark turned out to achieve the #1 performance in all the both with a significant margin to compared to other approaches. I think
Congratulations.
thank you. This is, I think, the first multi-agent attempt. It's very preliminary because we know there are many other improvements we could make. But this basically demonstrates the big potential of AutoGen, using AutoGen to solve complex tasks. And we definitely wish to see more progress in this. I've seen others efforts from the community as well. For example, one community member built a multi-agent system to teach the agent to resist emotional manipulation of these language models. They leverage both the teachability and the group chat, the finite state machine-based group chat, to build multiple agents. And some of our agents are able to perform the teaching, to perform the learning, and some other agents will reinforce that learning, etc. And so that's, I think, a very interesting application in the security and responsible AI domain. By the way, I think this security and responsible AI is also another good promising application. I've seen many different efforts because they also leverage the capability of agents playing different roles. Sometimes you can use them to do red teaming, and other times you can use them to remind other agents and to perform mitigation. I think there's a lot of interesting ideas there too.
That's great, and congrats on that once again. Okay, so we just have a couple minutes. A couple of questions, or one or two questions that are maybe less related to agents specifically. Curious, like, are there one or two resources you recommend to folks who are building in this space, books or content?
Yeah, I think Andrew had the newsletter called Batch, I guess, and they also have a course. They offer many courses online, so that could be a good resource to check. Also, I think these days, so for me, I usually just go to our Discord server and see what people are doing with it. So that's the main kind of source of inspiration for me these days, to see what other developers are building. I often got inspired by the ideas, and having conversations in the community is also a good way to learn from others and make progress together.
Perfect. And anything that excites you the most about the future of AI?
Yeah, so we've seen a lot of interesting news recently, including building videos or building softwares. So I think we will see more and more such complex tasks tackled by AI. And definitely I see a future that AI is more capable, is increasingly capable of solving more and more complex tasks. And interesting, I think two directions. One is the capability of the model themselves. Because some application indeed benefit from the advancement in ML capabilities. And once we have neural capabilities, then what kind of agents can we build from them? They will offer also new ways of potentially of decomposing tasks and doing planning and addressing complex tasks. And another direction is having to figure out the right, like I mentioned earlier, to figure out the optimal architecture or optimal multi-agent workflow, so that you can best leverage the different type of models, different capabilities, and for different reasons. Some reason can be for achieving or achieving higher quality for the result, but other reason can be reducing the cost and making it easier to deploy. If we can make some of the agents using smaller but more specialized models, that we can potentially make them cost efficient, but also very good at performing certain roles or functionalities. So both advancement in model capabilities and advancement in like agent design, a multi-agent workflow design, or complex AI system design is what I'm looking for.
Cool. Very cool. All right. Thank you again. This was super informative and really appreciate the time.
Thank you for having me. I really appreciate talking to you.